For this question, we are told that x is in the span of these two vectors, this subspace, and we want to express x as a linear combination of those vectors. So we don't have to check that it's actually in the span. That's going to be kind of a byproduct of the work that we end up doing here. But something that is really useful to note here is that the two vectors that are describing the spanning set are actually orthogonal to each other. So if we do the dot product, we get 4 minus 1 plus 0 minus 3, so we get 0. So they're orthogonal, which does mean that we get a little bit of a shortcut for expressing x as a linear combination of those vectors. So we get to use our formula. I'm going to just denote these as, let's call it my v1 and v2. So my x is going to be x dotted with v1 divided by v1 dotted with itself, and then times v1, and then x dotted with v2 over v2 dotted with itself, and then v2. And this only works because those two vectors are orthogonal. And so we can just write everything out here. So get our v1s in place. So v1 dotted with itself. And it also, of course, only works because we do know that x is in that spanning set. If we didn't have that piece of information, it obviously wouldn't be a linear combination of these two things. And 2, 1, negative 2, negative 1, divided by the dot product of that with itself, and then in that direction. I'm missing a minus there. And these are relatively easy computations for us to go through and do. So I'll get 28 minus 1 plus 0, and 5 times 3 plus 15. And then on the bottom, 2 times 2 is 4, plus 1 plus 0 plus 9. And then times the first vector. So I don't know why I chose to write the v1 here and the v without writing the v2 over here. I guess I can be consistent and write it like this. And the other one, so I will have 28 plus 1 plus 16 minus 5 over 4 plus 1 plus 4 plus 1 v2, and just do these calculations. So 42 over 14 v1 plus 28 plus 16 plus 1 minus 5, 40 over 10 v2. And so yeah, so we get 3 v1 plus 4 v2. And maybe I will just write those back in so we can just check our work on this. So 3v1, so 3 times 2, negative 1, 0, and 3, plus 4 times 2, 1, negative 2, and negative 1. So that should be our answer. That's the linear combination. And we can go just one step further and do a little check by actually working this out. So what do we get? 6, negative 3, 0, and 9, plus 8, 4, negative 8, and negative 4. And we add those together. I get my 14, 1, negative 8, and 5. And that is exactly x. That's it. So it makes sense. Because it's in that spanning set, we should be able to write it as a linear combination. And because the two vectors in the set are orthogonal to each other, we get to use this formula.